555 timer internal circuit diagram. The internal block diagram of a 555 timer is shown below. It consists of the following: 2 comparators, an SR flip-flop, 2 transistors, a resistive network. The comparators are the basic op amps. The comparator 1, which provides the R input, compares the threshold voltage with a 2/3 VCC reference voltage. The comparator 2, which provides the S input to the flip-flop, compares the trigger voltage with a 1/3 VCC reference voltage. The resistive network of 3 resistors will act as a voltage divider circuit. The values of these resistors are 5K ohms each. These 3 5K resistors are responsible for the name IC555. Out of the 2 transistors, 1 transistor is a discharge transistor. The open collector of this transistor is connected to the discharge pin, pin 7, of the IC. According to the output of the flip-flop, this transistor either goes into saturation or cut off. When the transistor is saturated, it provides a discharge path to the capacitor that is connected externally. The base of the other transistor is connected to the reset terminal, pin 4, which resets the timer irrespective of the other inputs. 555 timer working. The 3 5K ohms resistors form a voltage divider network. This network provides 2 reference voltages to 2 comparators, 2/3 VCC to the inverting terminal of the upper comparator, comparator 1, and 1/3 VCC to the non-inverting terminal of the lower comparator, comparator 2. The inverting terminal of the upper comparator is connected to the control input. Generally, control input is not used and is connected to 2/3 VCC. The other input of the upper comparator is threshold and its output is connected to the R input of the flip-flop. When the threshold voltage is greater than 2/3 VCC, i.e. the control voltage, then the flip-flop is reset and the output goes low. This will turn the discharge transistor on, transistor goes to saturation, and provides a discharge path to any externally connected capacitor. A trigger input is connected to the inverting terminal of the lower comparator. When the trigger input is less than the reference voltage, 1/3 VCC, the lower comparator's output is high. This is connected to the S input of the flip-flop and hence the flip-flop is set and the output goes high and the timing interval starts. As the output is high, the discharge transistor is turned off and allows charging of any capacitor connected to it externally. Hence, in order for the output to go high, the trigger input should be less than the reference voltage momentarily. The output is low when the threshold voltage is greater than 2/3 VCC, which resets the flip-flop and hence the output. Meeting timing requirements is a high priority task in most of the operations. For example, the heating process of a metal or a material in an industry is time limited. Hence meeting the specific time requirements can be achieved by timer circuits. A basic timer circuit is shown below. It consists of a charging circuit, a comparator, and an output unit. The charging circuit consists of a resistor and a capacitor. When a series combination of an RC circuit is applied with a DC voltage, the time taken for the capacitor to charge to the peak value is controlled by the resistor. The charging time is proportional to the value of the resistance. The rate at which the capacitor charges in an RC circuit is given by time constant. RC time constant, generally called tau, represented by the symbol tau, is the time constant of an RC circuit, which is the time taken by the capacitor to charge through the resistor by approximately 63.2% of the difference between initial and the final values. It is also equal to the time taken by the capacitor to discharge to 36.8%. Time constant of an RC circuit is equal to the product of R and C. Tau equals RC. As mentioned earlier, when the trigger input falls below 1/3 VCC, the output of the timer goes high and the period for which this stays high is determined by the RC time constant. The pulse width and the frequency of the output of the 555 timer are determined by the RC time constant. Choosing timing components for RC circuit in timer. A 555 timer can provide delays from microsecond to hours depending on the values of R and C in the charging circuit. Hence it is very important to choose appropriate values for resistors and capacitors. When the 555 timer is operating in astable mode, then it requires an RC circuit consisting of 2 resistors and a capacitor. And in case of monostable mode of operation, the RC circuit comprises of a resistor and a capacitor. Timing capacitor. Choosing capacitors with large capacitances will be a problem. This is because electrolyte capacitors with large capacitances often tend to have wider tolerance limits. So the actual values and the marked values may have a significant difference. Large capacitance electrolyte capacitors will have high leakage currents which can affect the timing accuracy as the capacitor charges. When choosing capacitors with large capacitance and low leakage current, tantalum capacitors are a better option. It is better to avoid electrolyte capacitors that have a high working voltage rating as they do not work efficiently when operated at a voltage 10% less than their rated voltage. Hence, capacitors with working voltage greater than the VCC of the 555 timer should be chosen. Timing capacitors with capacitance less than 100 pF in order to produce short output pulses may also cause problems. For capacitors with such low values, stray capacitance around the circuit might affect the capacitance of the timing capacitor.